Well, hello everyone, and welcome back to Adrian's Digital Basement. This is a continuation of the last video where I went into this banker's box here and I found a whole treasure trove of very interesting cards, like this mysterious video card here. This is going to be a continuation where I actually try to test some of this stuff and see what here actually works and what doesn't. So without further ado, let's get right to it. Now, when it comes to testing all the stuff that we took out of the box on the last video, there's way too much to test in this one video. The last video was already rather long, and that was really just sort of unboxing and talking about everything. So I'm going to quickly breeze over some of that testing and cleaning that I did on some of the more run-of-the-mill cards, and we will get to actually trying out some of the more interesting stuff, or at least the stuff that I think is a bit more interesting. First, let's talk about my method for cleaning and washing cards and motherboards when I get them. I simply take them up to the kitchen sink, put some warm water on, and I use a little brush and some soap and water and just scrub the cards. Typically what I do is I just do the soap and water and brushing of the front and the back of the card, and then before rinsing it, I actually stack up any of the cards I have to clean and kind of lets the soap soak in a little bit more. And then I go ahead and I rinse them all off. For things like motherboards, I will remove simple to remove parts like the CPU, but to be honest, I don't even take stuff out of the sockets generally unless it's really, really dirty or there's any kind of corrosion on the board. Otherwise, I'll just leave stuff in the sockets as well, and it's generally completely fine. At this point, I've washed hundreds of boards this way, and I've never had any issues. Although, keep in mind that I wouldn't wash something mechanical like a hard drive like this, and I also tend to stay away from things that have transformers on board, so power supplies and stuff. I won't generally do this method for washing. But all the other parts that are on these cards are totally fine with water and whatever, and as long as you dry them off before you use them, there won't be any problems. Next thing I do is I dry them off. Now, a while back, a viewer donated this blower thing that I have here. It's an ESD safe blower. It's basically like a vacuum cleaner without the suction part, and it has this nozzle that emits a ton of air. And as you can see here, it really just, well, the water just sort of sheds off the board. And I just spend a few minutes going over the front and the back, but especially the front of the board where all the chips are, and I just make sure that I don't see any evidence of any other water coming out of the board, like from underneath chips and stuff like that. You have to spend a bit more time if the board is very dense, or say a motherboard which has a bunch of slot connectors, because a bunch of water can get stuck in there. So you want to make sure that you get all the water out. I like this method personally because I'm only using soap and water and then air coming out of this blower motor. So there's really no chemicals or anything like that I have to breathe in the fumes of. And with water, you really don't have to worry about residue and stuff like that unless you have potentially maybe really hard water. But here in the Portland area where I live, water is very, very soft and it doesn't leave any obvious mineral deposits behind. So cleaning the stuff like this has always worked perfectly for me. Your mileage may vary, of course, and you might want to do a final treatment with some deionized water or distilled water, like a final rinse, before you then try to blow dry all the water off. I'm sure a perfectly good method as well would be just to hang the cards up, like off a little clothesline or something, and allow a breeze or a fan to blow on them, and that would probably dry them off perfectly well as well. I just find using this blower motor works well for me because it actually basically totally dries the cards, and after a few minutes under the blower, I've gone ahead and I've used stuff and it's always worked perfectly because it really does get rid of all the water. In this case though, I did do this washing several days ago, so these cards have all had about 3 or 4 days to sit around and dry off in case there was any residual water hiding.
8-bit testing. 16-bit testing.
For testing all the sound cards, I'm using the diagnosed utility that came with the sound blasters, and who remembers these particular test sounds? They're burned into my memory from, I don't know, back in the day, I guess when I was using my own sound blaster cards, or maybe when I was building PCs or whatever. I seem to remember all of these sounds really well. I also use OpenCubic Player, which is a module player for MS-DOS. It works really, really well, has excellent compatibility with all the sound formats, and does a great job playing back the modules in a way that sounds really authentic. If you're playing really old ones from the Amiga, they sound great, and also all the newer Impulse Tracker and Scream Tracker files sound really good as well. I now have one of the AW64 cards in the computer, and I'm going through all the test sounds here, and everything sounds completely normal. Of course, the one addition is it has wavetable sound built in, and here I am rocking out to that. Incidentally, both of these AW64 cards have 512K onboard memory. There is some kind of a RAM expansion you can plug into the board, but it doesn't use normal memory modules like the Sound Blaster 32 I showed in the first video, which I have expanded to 8 megabytes of RAM. These seem to be compatible with the AW32. I don't know what additional features they have, but things that are written for the AW32 specifically, including ones that use the sample memory or the onboard RAM, work without issue with these cards. Here I am playing some MIDI files, and they sound, well, they sound like general MIDI with lots of reverb and whatever other effects that you get with that. If you like the sound of this, then it sounds great. If you don't, well, you know, it doesn't sound so great. And then back to OpenCubic Player, but with the AW64, it does support using the card to do the hardware mixing of all the channels, and that works perfectly. I've tested this before on the Sound Blaster 32 or the AW32, works great. Seems to work just as well on these cards. You are limited by the 512K of sample memory though, so large mod files don't work. These AW64 cards do have full OPL 2 and 3 compatibility, and here I am using the AdLib Jukebox program, and it works perfectly. There's a little bit of background noise right now because the air conditioning is running, and I'm sure that the emulation of the OPL chip's not perfect, but it sounds perfectly good to me. And this is the result of the testing. So we had these two AW64 cards, and as you just saw, one of them was working, but they both actually work perfectly. And then these two Sound Blaster 16s, these are the two that look very similar, except one is missing the IDE interface or whatever, the CD-ROM interface, along with the audio amp. Both of these work absolutely perfectly. And then this Sound Blaster 16, this is the larger of the Sound Blaster 16 cards that I got here. Well, this one works perfectly, meaning all the sound tests I did worked fine, but I wrote an N here next to the check mark because it's weirdly noisy. And when I say noisy, I'm talking about the background hiss of the card. It's just much louder than it should be on any other Sound Blaster 16 I've ever come across. These other ones, for instance, sound perfect. You know, there's like a tiny bit of background noise, but at normal listening levels, it's not really a problem. But on this card, it is a problem. And if I turn down the gain and stuff in the mixer, yeah, the noise goes away. But if you turn up the gain in the mixer where you can hear the card properly out of the outputs, well, then it doesn't sound good anymore. You get that background noise. But then the highs and the lows and all the other sound that actually comes out of the card sounds perfect. In fact, the weird thing is while running the diagnose test, that's the Sound Blaster utility you saw me running just a moment ago on this card, perfect with no background noise. But as soon as you exit the utility, the background noise comes back, and then any other program I run with this card, yeah, it doesn't sound really good. So that's a little mysterious, and maybe there's a bad capacitor on here. I'm not totally sure, and it's something I haven't run into before on any other Sound Blaster 16 that I've worked on. Moving on to the non-sound cards, we have the 3Com 3C509. This card works perfectly. I ran it with a packet driver and got it working in DOS. So that's pretty cool. And then we have some video cards. We have this Trident PCI video card here. This works fine, no issues. It's actually decently fast as well. I mean, it performs as you would expect a PCI video card to perform. I have some other ATI PCI cards that perform terribly, so this is better from that perspective. And then we have this card here, which actually is one card that is not working. The issue is the video output quality is really bad. It's very, very dim, and there are these vertical lines in it. I think there might be some problems here with the DAC. It's a BT DAC that's on here. I did take out that chip and I reseeded it with some deoxit, but that didn't really seem to make any difference whatsoever. So either something around this area might be bad, or it could be that the main chip is bad as well, although I really do suspect there's something wrong with this. Depending on what was displayed on the screen, you had varying levels of like kind of static and interference and dark spots and stuff like that. So unfortunately, yeah, this card is not good. Performance testing seemed to indicate that it was an okay card, nothing particularly special. Luckily for me, I have a bunch of ISA video cards, so I'm not like dying to have this particular card working, but I was kind of curious to see how this thing worked with this particular S3 chip on here, which I'm just not super familiar with, but alas, it doesn't work. Oh, and I did try changing the switches here, just different settings, stuff like that, and it made no difference whatsoever on the output quality of the VGA. So like I said, there just appears to be a fault on this board. And then the last card I tested was this video card here. This is the VTech one, 8-bit, and it works perfectly. And here's something that's a little bit amusing. Notice right here on the chip, looks like someone scratched something off there. Well, I have another one of these cards, and while I was organizing last night, I found it, and it's identical to this. And the other one just says VTech right there. And this one, someone didn't like that, or maybe this was sold in a non-VTech machine. They wanted that scratched off. I don't know what the deal is. But like I said, this card tests perfect, and it is slow because it's only 8-bit, but you kind of have to take that for what it is, because if you want to use VGA in an XT class machine like a 5150, well, this card will work perfectly in there, and the compatibility seems to be fine. It doesn't have a lot of video RAM, so it doesn't have a bunch of VESA modes and stuff like that, but it does output a nice clear picture, and it's VGA, which means it's widely compatible with things like LCD monitors, which is great. So that's it for the quick test of all these run-of-the-mill cards. Let's move on to some of the more interesting things. All right, here is that 46 motherboard. Now, I did give this thing a nice wash. I didn't really show that in the footage there, but it's spick and span and looking absolutely brand new at this point. First things first, for testing this thing, I want to get these little standoffs off here, and a Bic pen that a viewer sent in is a perfect implement for getting these off. That really does make it really easy to get these off. I wish I knew about this when I was working in a computer store in high school, because I always struggled to use some needle nose to get these off, and well, just take a Bic pen, pull the ink out of there, and then that is cinch. Now, we have two processors to test out on this. We have one that is just a normal 4633 megahertz here that is quadrupled to 133. And then we have this chip, which is what was in this board when I found it, which is an AMD DX4 120. So let's put the 120 back into this board, and we'll start testing with this installed. And the thing is about 46 boards that you may not be familiar with if you're used to Pentiums or later boards is you do have to set a bunch of jumpers on here for each of the specific CPUs. Starting with the CPU that was already in this board means that the jumpers are hopefully configured already in the correct configuration for this CPU, which means that hopefully it should just work. For RAM, we're going to use some of this FPM memory. So there are two types of 72-pin memory, which is what this motherboard takes here. FPM, I think, stands for fast page mode or fast page memory, and the other type is EDO, or extended data out. EDO memory only works on some specific 46s that have a chipset that supports it, and FPM is the older type that should just work on everything. So I went ahead and I tested all the memory I have with the RAM tester, and luckily that thing tells me if it's EDO or FPM, because it can be very difficult to tell when you just look at the memory modules. Sometimes it's written on a sticker, but it's not always. So for the RAM tester, it's been very helpful for me, because if this motherboard doesn't support EDO, usually the system might boot, but then it freezes at boot and it won't work properly. So just knowing that I have FPM memory is going to make it easier for testing this board. Now, depending on how familiar or not familiar you are with different Intel processors, the 46 processors and 386 processor has a 32-bit external data bus. 72-pin memory modules like these also are 32 bits wide. So on a machine like this, you only need one of these to make the system work. When the Pentium was released as a follow-up to the 486, the Pentium doubled the external data bus from 32 bits to 64 bits. And if you have a Pentium board that uses 72-pin memory modules like this, you actually need two of them at a time of a matched size to get a working system. The later memory modules that came out after this were the 168-pin SDRAM modules, and those are 64 bits wide. So on a Pentium board, you only need one of those typically. And if you have a 46 board that happens to have those, then one of those modules is going to take the place of two of these 72-pin modules. Now, you're not really going to be able to see it, but I could just see down there that this is SIM 4, 3, 2, and 1, with 1 being the one furthest away from me. So I'm going to populate the memory modules starting with slot 1. A lot of times it won't necessarily matter. It just depends on the chipset and whatever. But that's the way I'm going to populate this. In fact, I'm only going to put one of these modules in. We don't need to put two in. This is an 8 megabyte FPM module, and 8 megabytes of RAM is plenty for testing this machine. As I had mentioned in the last video, this thing has plastic slots, which is kind of annoying because plastic slots are really fragile, although these seem to be pretty durable. So I'm not as worried about these as I am with the 30-pin sockets that are on Macintoshes. Those break all the time. All right, I use my power supply here for a little like test bench basically, but I don't like to put the motherboard, the bare motherboard right on here, even though I have these little feet on here. So I usually just stick a mouse pad on there, put that there. That way I don't have to worry about any potential short circuits that can come from the motherboard sort of bending and touching the metal of the power supply. Now for PC motherboards that have ISA or PCI slots, I highly recommend you use something like this, which is a post analyzer card, POST, Power on Self-Test. Machines from the IBM 5170, that's the 286 and beyond, produce post codes, which are numerical diagnostic codes that will show up on a card like this. They're written to an I/O port, and you just plug this card into the slot and it monitors that I/O port, and it will just display on this little LED display here. That allows you to know if the motherboard is working, even if it's not initializing the video or has some other problem. As long as the CPU is executing code and it's running it from the BIOS, then we should see a code on the card here. So I'm not going to even plug in anything else into this board except for the post card, a little bit of RAM, and the CPU, of course. This wire here comes from the card, and that's because this card has a little speaker on there. So I'm going to plug this in, and that way we can hear if it's beeping as well, which is also a really good diagnostic aid. Now remember, I haven't validated that the jumpers are correct on this board. The jumper configuration and stuff like that is available on the retro web. I already looked. So if this machine is not posting in a second when we turn it on, then I'm going to go and start to validate all the jumpers and whatnot. I do not have a heatsink on the processor right now, and this processor does require a heatsink, but if I just turn it on quickly and it starts to post, then I will find a heatsink and stick it on here, and then we'll go from there. It'll be fine to run it without a heatsink for just a little bit of time. All right, so I'm going to hold the motherboard right here like this, so when I turn it on, you can see the post codes as well, and here we go. Good, it's posting. So that's a great sign. That means that, well, the CPU is executing code, and we need to plug a video card in, and I get a heatsink on here, and we'll see how it goes from there. We're going to use this video card here. This is the Trident PCI card that I tested, so we'll pop that in there. I'm going to plug in this keyboard here. This is my little mini keyboard that I sort of use for everything. I have the open source scan converter connected to the video card right here, so we can capture the output. And then for a heatsink, I happen to have this Cyrix heatsink here, and it has sort of a thermal pad on it. That should be good enough for keeping this chip cool. It doesn't really need a bunch of thermal compounding or anything. It's not like a high performance modern processor. It just needs something beyond this ceramic substrate here. So like I said, that should be fine. If I was going to run this for a longer period of time, you'd want to like stick this down and have a fan that blew on it or whatever. But for short testing, there should be no problems. And the test pattern you're seeing right now is my open source scan converter being captured by the capture card. Let's turn this on, see what we get. Oh, wait, I heard a beep. Maybe we're getting a signal here. There it is, everyone. It's freaking working. It's running at 120 megahertz, which is the correct speed. Now I think about it, floppy drive failure. Yep, there's no battery in here. So what I should do is grab a battery and stick it in the motherboard. Alrighty, I put a battery in there, and the machine was on for, well, it was on for a couple minutes, and the CPU is not even warm, not even a little bit. That is the benefit of these 3.5 volt CPUs versus the older 5 volt Pentium, or sorry, 46 processors. We got no signal here. Let me get the remote for this thing. Oh, there it is. Let's get into the BIOS settings here. Well, this capture profile on the open source scan converter looks decent. It's just shifted over to the side. So just ignore that a little bit. It's one of the problems with VGA cards. And obviously, if you've ever used an LCD external monitor, you know how you have to auto configure it periodically. And the open source scan converter is the same thing, but it doesn't have an auto mode. So you have to kind of adjust the profiles yourself. What kind of options do we have in the BIOS here? I don't know, everything looks pretty run-of-the-mill. Let's just turn off the floppy drive because I'm not going to connect one up. BIOS features, we have internal, external cache, quick self-test, auto configure on and off. I think I'll just leave this as it is. Hopefully DRAM speed as slower is not, well, not automatically detected there. As familiar as I am with PCs, I'm not always familiar with all the settings like burst rate, enable or disable. Which one speeds it up? I don't know. Right back or right through, which is the faster way of working. I think right back is the faster way. You could enable or disable the onboard IDE ports that are on here. So we'll just leave those enabled, and the floppy control and parallel stuff. Power management, well, we're just gonna leave that stuff as disabled. PCI, plug and play BIOS autoconfig. I don't know, we'll just leave that disabled, I guess. It's the default because the battery was out of this thing anyways. And there's some other settings here which we will just leave as they are. Alrighty, and we'll save, exit. Now, of course, there's no way for this system to boot because I don't have anything plugged into it. So let me grab my XT IDE card. Even though this thing has IDE built on the motherboard, it's just easier for me to use the XT IDE. So XT IDE in, we'll pull out this postcard because I don't need that anymore. Let's boot up into DOS and we'll run a few quick performance benchmarks, see how this thing is performing. Now the computer's been on for a couple minutes, the processor is just ever so slightly warm, and that's with this thing just sitting on there. All right, with the system booted up, I'm gonna quickly run Speed 600, just the landmark speed test. This is very fast, 120 megahertz it shows there, but those speeds are great. And 10,000 characters per millisecond is really good performance. This card, when I tested it inside the Pentium system, I was testing it in my Pentium 200, it wasn't even scoring as high a score there. I think it was getting something like 9,000. So it's actually a little bit better performing on this PCI bus. Now, when it comes to 46 motherboards and all the different permutations you can get, there are some that I'm aware of that have relatively slow PCI bus, and there are others that are much better. I'd say that this one appears to be working properly because at least this video card is fast. I don't have anything else plugged in here for us to really test, and you could ignore the disk speed in this program because, of course, this is on an 8-bit ISA bus, so it's really slow. But let's look at the performance here. So the processor itself is getting a 44.58, which according to the little graph there is nearly what the AM586-133 should score. And remember, that's this chip right here. This is the 586 chip on a little accelerator board, but maybe there's like a few points difference or something like that. But what I really wanted to see was the cache memory performance in this thing, and you can definitely see that it's got functional cache. In fact, the onboard motherboard here has 256K of cache because you can see that yellow line there is very fast, and that's the internal L1 cache in the processor. Then it drops down, and then it goes all the way to 256K, and then it drops down again. And that is the onboard cache memory on the motherboard here, which is quite warm, by the way, working properly. And the processor itself, it's warm, but it's also not too hot. What we can be sure of, though, is that the cache is not working at all for the writing because that blue line is just solid all the way across, which means that we're not getting as much performance as we hoped. So there might be a setting in the BIOS that you can tweak to try to improve that setting. But I think for this video, I don't want to go and spend hours tweaking all those settings to try to maximize the performance of this board. I think we need to move on to testing some other things. So I'm going to power this off, and I'm going to draw a check mark on this board just to indicate that, yes, for sure, I have tested this and it works. What would be a good spot for doing that? I'm going to do it right here in this green area. So we get a little tick mark there, and I'm going to do the same on this AMD processor, just so I remember that I did test it, and it does work. Now for testing this processor here, what I'm going to do is I'm going to grab my other 46 motherboard, and this is one that has a DX266 on here. The reason why this is good is because this is already configured for 5 volts, and of course it's set for 33 megahertz. And it has this, if as long as none of the pins are bent, should go into the motherboard. So let me plug this into power, and let's see if we get posting on this motherboard, and we should be getting some decent performance at that 133 megahertz quadrupled. Turn this on, and we do not have a posting system there. So let's try to see what happened here. First thing I'm looking at are the pins on here, and none of them are damaged. Everything looks completely perfect, so that is not a problem. But we obviously did not have a working system. But you know what? I don't think this was in all the way. I think that was the problem. Okay, let's try this again here. See if that makes a difference. Yes, we have a post code there. Oh, and it's beeping. Yeah, this motherboard, I hot glued a speaker on here. I hot glued a power LED, and there's a little reset switch on here as well. All right, cool. So it's working. Let's plug in the video card and the XT IDE. For video, how about we use this VTech card here, even though it's 8-bit, I know, but that's good enough for testing purposes. Why do we have no picture? Oh, there it is. Just took a second. 132 megahertz. Looks good. The image quality through the capture device, not super great. When I hooked up to the LCD, it looked fine. This card, that is. 5x86 133, and it's getting 42. Were we getting 44 on the last one? Here goes the memory test. So yeah, 16K of cache. Oh, the memory bandwidth is 46 megahertz, or megabytes per second. Much faster on this motherboard than on the last one. I think we were getting 20-something megabytes on the last one. So the BIOS on the other motherboard definitely needs some tweaking to maximize the memory performance. And it does kind of suck, because back in the day when you didn't have tools like this for, you know, tweaking and testing your performance, you didn't always know like the right settings to get the maximum performance. Look at this, the right line is the same, it's just going straight across, which means that the cache I don't think is working here either. Anyhow, as I was saying, if you didn't have tools like this, you didn't have the know-how to go in your BIOS and tweak all those settings, you weren't probably maximizing the performance of your system, kind of like this motherboard right here, like whatever the settings are just a lot better than the settings on that last motherboard. Hence, the RAM performance here is just far greater. Now, as far as like the performance of the processor, it's a 42, whatever we were getting last time, either 42 or 44, whatever it was. The thing is, your memory speed may have a big effect on certain programs and other programs, not so much. But definitely, if you are not tweaking those settings, you are leaving stuff on the table. So there it is, 16K of L1, 2K of L2, and the memory throughput is 25, but that includes, I think, the reading and the writing, so you can kind of ignore that. I'm noticing here in the landmark speed test, well, look at how slow the video is, 677 characters per millisecond. That's on this 8-bit video card right here, and we're getting like over 10,000, or was it 12,000, or whatever it was on the other motherboard. So more than 10 times the performance of the video. But the CPU speed is 624 megahertz here, and I kind of recall on the last one it was like 500 and something. So this processor is definitely faster, at least in this particular benchmark, and it does show 134 megahertz in here, although this does not have the best performance test. It does show that this CPU though is running at full speed, and what a cool little processor. You just dropped it into whatever computer you had, as long as it supported 33 megahertz 46, and it would just freaking work. Massive, massive performance improvement right there. I'm going to pop out this processor and I'm going to stick back in the original DX266, which I normally keep in this motherboard. And let's see what we get on Speed 600 with this thing in here. And we are getting 316 and 453, and I wrote down what the last one was. It was 624 and 771. So it's basically double the performance of this DX266, which is definitely, this chip is double the performance of the original 33 megahertz, at least in this test. So really, this little chip does what it promises, and it quadruples the speed of your 46 with a simple drop-in chip. That is freaking cool. So I went over to the table there and I grabbed a few more of the cards here that I want to test out, and I think at least some of these I should be able to get working. This card on the top is the Heath 150-307. And while this looks just like an EGA card because it has an 8-bit bus here and the Chips and Technology chipset on here, it seems very much, or kind of screams that it's an EGA card. Apparently, from my reading, this is actually an EGA card, but it can output VGA resolutions, and it actually has a VGA 15-pin connector on here to output an analog video signal. From what I was reading though, is when you have a VGA monitor connected to this, you're still working with an EGA card. So software that's written to talk to EGA cards, which is what this is going to look like, are only going to output EGA resolutions, and the 640 by 480, which is the typical VGA graphics resolution, won't be available. And I'm assuming that that is possible on this card if you have software specifically written to use it. So let me clear away these other two cards actually, and let's just focus on this one first, see if I can get this thing working and figure out how it works. So the thing about this card, it has a cutout here for 16-bit slots, but the problem is this part hangs down, which means it's going to interfere with all this stuff. So I'm going to need to grab another motherboard that doesn't have as much junk in the trunk, so to speak. And that honestly is why I keep my 3D6SX motherboard handy, because that motherboard is much easier to use cards like this that have like weird stuff going on. So first I'm going to plug in the capture device, which we were just looking at with the other video card. Let's see if we get any kind of output out of this card whatsoever. But we have no video whatsoever. I switched over to the RGB to HDMI and I have it set for EGA Model 2, and we have a cursor. Let's reset this computer here. See if we're getting anything. I don't know why we're not getting any image, well, other than a cursor, but that is saying that it's initializing. Although, why is it that sort of teal color? That's a bit funky. Now, even though there's a flashing cursor, the postcard is showing a code of 36. And it seems like the computer is not fully initialized. So the card's initialized, but the computer's hung. So I'm going to need to try to figure out these dip switches here. Well, after a little fiddling around, I was able to find the right switch settings to output VGA, and we have a cursor there. And according to the open source scan converter, it's actually running at 31.46 kilohertz at 70.39 hertz. So that's close enough to the VGA text mode. But we are getting exactly the same flashing cursor thing going on there as we were before when we were getting an EGA type output. So I'm wondering if there's something wrong with this card. That's it. We get no beeping on this motherboard. It's stuck at postcode 36 for an AMI, and I cannot hit Control-Delete. That does not do anything at all. In fact, the keyboard appears to be totally dead. So what we can tell is that this thing is definitely initializing the video correctly. We're getting a correct VGA output with a flashing cursor, and we were getting an EGA cursor before. And the only thing I'm thinking is I wonder if I need to switch this jumper here. It's set to the top setting. Let's move this down to the bottom setting. See if that has any effect. There are a couple more jumpers over here as well, VJ1 and VJ2. So we'll start with this in the down position, and we'll see if that makes any difference at all. So we're getting no output at all at this point. So for the jumpers, by the way, this lower one, up, down, down, up, down, is VGA, and that's what I found on the Vogons thread. It was set to up, down, up originally. So I don't know if that's EGA or what, but I'm writing these down so I can figure out what the right settings are. And we know here with this jumper in the down position, that results in a system that doesn't work at all. And here on the Vogons thread as well, there are the two jumpers there, and those are both not populated on both of these cards. So it seems like everything on here is configured in exactly the same way as these cards on the Vogons threads. Oh, there's another jumper right here. Let's double check that one. It's moved towards the video connector on that card, and this card is the same thing. And on this card, it's configured just like that as well. And there are also some pins right there that aren't plugged into anything. That almost looks like a light pen connector. And then on the Vogons thread, there's a picture right here. Yeah, there's nothing installed on that. So that is not a jumper block. So I'm wondering if the problem maybe are these dip switches here. They're a little dusty. Maybe I need to blow some contact cleaner into there and move them up and down. I've definitely had it before where some, I don't know, like gunk or whatever gets inside the switches and it prevents them from reading properly. So just moving them up and down seems to kind of help the situation. And no difference, we're just getting a flashing cursor. Now it's quite possible this motherboard is not compatible with this card, maybe, or maybe that these like large PLCC chips aren't in these sockets properly. We're getting a good picture though, that's the weird thing. So like the card's being initialized, but it is not working. So let's pop these chips out of here, and then I will deoxit those sockets. I have some deoxit in this little drip bottle here. To be honest, I'm not really holding out hope that this is going to improve the situation at all. But you never know. I think I've had this fix problems on Amigas before. So let's just keep trying, right? And last but not least, let's take this BIOS chip out of here, and we'll deoxit this socket as well. This card's in really good shape. I didn't have to wash it or anything like that, so this has not gone through the cleaning cycle. There we go. This is the DAC, and that's working because we had a good video output. Everything else on here seems fine. And I think we are in the same boat. Yes, we are. The last thing I can try here is swapping out this motherboard with something else. Let's just see if that makes any difference whatsoever. But I'm not holding out hope, unfortunately. All right, we swapped over to the 46 motherboard. Let's see if this thing makes a difference. Power that on. It's posting. Whoa, it's working, but why is it all red? What the heck is going on there? So it didn't like my 386 board. Come on, go into the setup. This card is causing weird issues on this machine too. It seems to be frozen here. And I switched back to the RGB to HDMI, which is what we're looking at here. Let's see if we get an EGA signal out of this thing. I mean, it's beeping. It says no signal. Look at that. I know you might think this is the VGA output, but no, this is the EGA output. And it's working, but it's doing the exact same thing. Although it's funny because when I had the other card in there, I noticed the EPA energy preventer, pollution preventer, whatever thing, faded away. And I wonder if this BIOS is trying to do that. And this EGA card cannot handle that and is freezing. And maybe that is also why we have this red color. So I think I need to grab yet another motherboard and we'll see if this works on something else. Now we're back on the motherboard that has the 120 megahertz processor in it. Still has the EPA energy preventer thing, but look, there's no red on this one. And it did work. And I hit Control Delete. That rebooted the system. Now this motherboard might have the exact same problem as the other one with that EPA logo trying to fade away. And it's causing some kind of an issue here because it's just hanging up as well. All right, yet another motherboard here. We have a 386DX motherboard. I've previously had this on the channel at some point. It's got the Mathco processor in it. And look, it's counting up memory. Now, at this point, you might be thinking, I have been fiddling around with this card for quite a while. And yes, that is true. And this is kind of the reality of this like weird unknown hardware. There's no documentation for this card. And all you can really do is just trial and error. Keep trying different cards and different motherboards and different settings until you get a system that maybe works. Well, this card is just really a curiosity because, you know, what use is it really when you have VGA cards like this? Look, it's actually trying to boot. It's actually freaking trying to boot. That's amazing. When you have VGA cards like this that work in XTs and they're fully compatible and just easy to go, you just plug them in and they just work properly. It's a much better solution than a card like this that has these weird limitations where, well, what is this? The fourth motherboard we tried and now finally it's actually booting the system. C prompt, yes, there we are. Wow. It's really, really slow. I mean, this is a 386DX motherboard. It's pretty speedy. But this card has some really poor performance. 440 characters per milliseconds. Remember when I had this card in there, I think it was the VTech card, we were getting like 770 over the 8-bit bus. So way, way faster than this card. It is working at least. You know, we're getting EGA out of this and the resolution looks correct and everything. And ignore the fact it's not taking up the full screen. That's the RGB to HDMI. And we'll do some video tests here and check it, see what we're getting here. So this should have 256K of RAM. So it's acting like an EGA card. So far, so good. Everything looks like it's working here. A few of the modes are shifted over to the side, but that's not a big deal. So there we go, normal TTL colors. All looks correct. Ooh, this is weirdly squished. So CGA. There are the TTL 16 colors, and all looks correct. And there it is again in the 640 by 200 in 16 color mode. There should be one more of these. There we go. 640 by 350, 16 colors. Look. So I'm here in the program vid test, and this actually is going to use more of the EGA color. So CGA doesn't support a lot of these colors. Notice there's like 3 shades of green, 3 shades of red, 3 shades of blue. And that is part of the 64 color palette that EGA actually supports. This is beyond just having a single intensity bit, but it's actually having, I think, 3 intensity bits. So we're talking about RGB plus 3 more bits instead of 1 extra bit. And that gives you more colors. So there are more than this that are possible, but this particular program only displays these. And I actually don't have any other programs that can display all of the 64 EGA colors. So we're kind of stuck with this one as a test. Now I'm curious, if we swap these switches back to the VGA mode and we turn this on while the EGA cable is still connected, what are we going to get exactly on the RGB to HDMI? I'm assuming we're going to have like some kind of a rolling image. Or nothing. It looks like we have nothing at all. So plug in the VGA cord, I switch back to the open source scan converter, and I can see it just syncing up right now at 31 kilohertz. And like I said, this is a very interesting mode because it appears to be VGA, at least from a resolution perspective. But if we go to check it, I think it's still going to show up as an EGA card. And indeed, it says EGA here. And if we look at the graphics tests, let's see if we actually have that 640 by 480 like the VGA test. I don't think we're going to have that. So far, all these tests are looking fine, and you can ignore a little bit of the like fuzziness or whatever. That's the scan converter again. So this is the EGA 640 by 350, which is why there's a little bit of a bar at the top and the bottom. And no, instead of going to 640 by 480, it went straight into the CGA test. So indeed, this is not going to try to use this or treat this like as any kind of VGA card. It's strictly EGA and very slow EGA, although EGA is always quite slow, outputting on a VGA connector. That really is an odd thing because generally VGA cards are fully compatible with EGA, and yet obviously they work on the VGA monitor and they support all the additional modes like the high color modes and stuff like that, that this does not support. This doesn't support 320 by 240 or 320 by 200 at 256 colors. None of those modes are supported. And sure enough, we go to vid test here and it thinks it's just a regular EGA card. Let's look at the 64 colors. Oh, come on, it's resyncing. Yeah, there we go. So that is working properly. But if we go to the VGA menu and we try to do, well, 256 colors, what's this going to do? Warning, error has occurred. Yeah, it doesn't work. And it took us back to the EGA mode. Well, so there we go. I think that's pretty much it for the testing. This card does work. It just has those weird limitations. Basically, it's very fussy about what motherboard it's in. It seems to only work in this 36DX motherboard. I'm sure it would work in older motherboards like XTs and 286s, but those later motherboards that have that EPA logo and tries to do a color fade, none of that works. And of course, I can plug a regular EGA card into those motherboards and it will work. But this motherboard, or this card, is fussy. It's a very, very fussy card. I did figure out without a doubt, these are the 2 configuration modes. So up, down, down, up, down, that's VGA output. And then up, down, up is EGA if you want to use this card with an EGA monitor. There are probably some other configurations on here that give you other types of TTL output, like CGA monitor compatibility, maybe even MDA. But without any documentation, which I definitely could not find, there is no way to know that for sure. Very oddball card, but it is working, so it does get the tick mark, but maybe I should put a tick mark and an F for fussy, because this card is fussy. All right, let's move on to another card that's probably going to be far easier to use. This is the Compaq card that should output CGA and MDA at the same time. Like I think it goes an auto switch or whatever. Are there jumpers on this thing? There's a jumper there. I don't know. I plugged in the RGB to HDMI. All right, and I put it into some auto mode. It seems to be running in some kind of like CGA type mode. Yeah, okay, this lost all of its CMOS settings. That's a sign. I'm going to switch back to the 36SX motherboard. That's my go-to for testing these old style cards. Alrighty, so this one worked. It did show up in 40 columns mode, so we'll switch this to 80 by 25, and there we go. And look how much faster this is. I mean, this is a 40 megahertz board, and that thing I think was 33, but yet this thing flies in comparison. All right, and as I thought, notice when I hit enter, it flickers. So that's typical for an actual CGA card. In fact, you can kind of ignore that it was kind of like blanked at the top there. That's just the way the blanking works. This will be a normal CGA card at this point. Why don't we run the CGA compatibility test? This is Jim Leonard's utility here. Do I agree to those terms? Yes, I do. Let's check out some of the 6845 compatibility. So display positioning, yes, look, it's able to move the image around the picture. Cool. Yeah, it's doing some scrolling. Now, I think this has more video memory than a typical CGA card, which is why maybe it's shifting over like that, but notice we're getting some smooth scrolling. Raster bars, and those are working properly as well. None of this works if you don't have proper 6845 compatibility on your card. I don't know if this thing is emulating that inside one of those custom chips or whatever. And yep, there's the row reprogramming, and that's working perfectly as well. So this is like a low resolution 16 color mode that looks really good. And the final test, if we go mode mono, function is not supported. So I was under the assumption that this Compaq card supported both monochrome text and CGA. So let's exit out of here and let's go to here and let's switch this to monochrome. Let's see if that does change this into mono mode. No, it didn't. It just went to 40 columns mode and it's complaining about being in the wrong setting. Yep. Okay, well anyway, this card appears to definitely be working properly, and that's a good thing. As far as it supporting like some kind of mono mode, definitely let me know. Don't think you have to set a jumper. There is a jumper right here that maybe changing this would do that. I don't know for sure. Maybe only when you have the internal monitor connected here does it do that. Either way, this VDU controller from Compaq is working properly. So this gets the tick mark of success. Alrighty, moving on to the next card. It's this one here. This is the Orchid card that was from 1985 based on the marking over here. And when you remove this memory module here with 320K underneath on the main PCB, it's silkscreen Turbo Graphics. And that's all we really had to go off with this card. I did some quick searching around in the last video. There's some bodge wires on the back and I really couldn't find anything. But since releasing part 1, some patrons have been doing some sleuthing, and one of my patrons uncovered this little gem about this card here. This little blurb was in a technical magazine from 1985, and it says a new product for the high-performance CAD and professional graphic art industries has been announced by Orchid. The Turbo Graphics Controller, or TGC, which is functionally compatible with the IBM Professional Graphics Controller, but it runs 4 to 25 times faster than IBM's product. It offers 640 by 480 display and can run on less expensive displays than IBM's. The IBM card required a special monitor, which looked very much like the normal IBM CGA monitor, but it was actually an analog RGB monitor, and I think it was a pretty expensive monitor, and a precursor to VGA or MCGA. This card writes directly to screen memory and has RAM designed specifically for video applications, approximately $2,000. That is it when it comes to information about this card. There is nothing else about it available anywhere on the internet, at least that we could find. I will add one caveat that I'm recording this before the main part has been released to the general public, which means that there might be some more information that's uncovered thanks to the sleuthing ability of more of my viewers. But at least at this point, this is all I know about this Orchid card. Now, you might be asking, what is the IBM Professional Graphics Adapter? Well, let's take a look at that a little bit first. I found this webpage here talking about the Professional Graphics Controller, and please note that some people call the PGC or Professional Graphics Controller the PGA or Professional Graphics Adapter, so I think those terms are pretty much interchangeable when talking about this card. So the general gist is IBM's Professional Graphics Controller came out for the XT, so in 1985, and it was extremely expensive, but for the time, it was also very, very capable. 640 by 480 by 256 colors out of a possible palette of 4096. Now the Amiga was coming out around the same time here, 1985, right? And it was very capable from a graphics perspective, but it could not do 640 by 480 by 256 colors, which when you think about this particular resolution, this didn't really become more standard until, well, the later VGA standards came out in 87 and beyond. And of course the Macintosh 2 line came out supporting this resolution. There were probably some Sun workstations and things like that that might have supported that resolution as well with those amount of colors. But in the PC space in 1985, not super common. The IBM card did support CGA emulation, although you could disable it and then run a CGA card in parallel for dual monitor support. And speaking of dual monitor, remember that that is not like extended desktop dual monitor like we're used to now. This was like 2 separate screens, so you'd be running, say, something like AutoCAD, where on the PCG, you'd be having your high resolution graphics, and then maybe you'd have like a toolbox with some text mode stuff or rudimentary color graphics on the other screen. So it was very application specific. Now scrolling down a little in this article shows the original PCG was an extremely complicated and very expensive card. It had 3 PCBs, including one with all the memory, and then this middle one which had the CGA emulation on it, which I guess was optional, so you didn't always have that. It did have a 9-pin connector, so that's matching how this Orchid card is here with a 9-pin connector. So I'm going to hope that it's the same, because the pinout for that connector is available in this article. Notice here that the original PCG does have a processor, so that means that you could send commands to this card for drawing boxes and shapes and things like that, and theoretically this card would accelerate that and do it more quickly than if the PC was actually trying to write to the video memory directly across the slow 8-bit bus. And to facilitate the communication between the host computer and the card with the processor, it used 2K of RAM up here in the upper memory space that was shared between the PC and the PSG that allowed that two-way communication to the processor. Now, the original PCG actually has an 8088 processor with 64K of ROM, so it's an entire like mini computer there on the card. So you can imagine how expensive this card probably was. There isn't really a lot of information on what it actually cost because it really sold probably to super high-end customers and in very small numbers at that. Now here's a pinout for the 9-pin on the IBM card. We'll have to plug this card in, see if it does anything by looking at the outputs here with an oscilloscope to see if we're actually getting anything that even mirrors this. That one little snippet on the Orchid card mentioned it uses cheaper monitors. And the only thing I can really think of is that maybe the fact that this is composite sync, which was a little unusual, maybe the Orchid card uses a horizontal and vertical sync, which would be more like a normal VGA monitor at the time. Now this article then goes on to talk about, well, the memory map and some of the emulated modes, but then all of the commands and stuff that this card supports. What's really not clear on this card is how compatible is this? It said it was a clone, that little snippet said it was a clone, but ultimately, we don't really know. And of course, there were some other cards on the market that were replicas of the PCG, but not all of them supported all of the commands, and maybe they worked a little bit differently. The fact that this says it writes directly to screen memory bitmap has me thinking that maybe this lacks the processor, because I don't remember seeing a large IC on here that would act as a processor. There is a 40-pin DIP right here, but if I recall, that was a 6845, which is not a processor, that's just a screen controller. Which begs the question, is this card really a PCG clone? And even if it is, how do we even test it? I think I'm getting ahead of myself talking about all this PCG compatibility, because the first thing we need to do is put this into this computer here and hook the oscilloscope up, and let's see if we actually get any output at all from this 9-pin connector. And if we do, then I can build a cable, we can try to hook it up to the capture device, and then see if this card is truly a PCG compatible card. Okay, so for the oscilloscope, because I don't need to see exact signals, I'm just going to use my little portable hand tech here. I'm clipped onto the first pin, and with the system booted up, I've gone through and looked at all the pins, and only pin 4 on this connector is actually getting any kind of useful signal. 9.7 kilohertz, 5 volts peak to peak. It's a square wave, and you can see it right there on the oscilloscope. Every single other pin on here is not outputting any kind of signal, and that's a bad sign. The system is stuck at 40. I don't have the speaker hooked up. I'm just going to pull this out of the board here, and let's just see if this also gets stuck at 40. So we're at 31, yeah, 40. So I have a feeling that 40 is what you get when the computer is not seeing a video card. And I'm sure if I hooked up the speaker, we'd be hearing beeping. So this card does not appear to actually be initializing at all. There is a jumper right here, so I'm gonna take the jumper off and we'll pop this back in. We'll just see if this does anything. It may well be that this card doesn't do anything unless you have a CGA card. And see how this expansion connector is not connected to anything? It could be that there's an extra module that goes on here that gives it CGA compatibility, kind of like the PCG card. And without it, this is a card that doesn't do anything on its own, and you need to use a regular video card. And with that jumper removed, there's no change on the output. We're still getting the exact same signals we were getting before. I'm just gonna set that jumper back to what it was. The card's pretty warm, that's for sure. Let's pop in a CGA card into this system here, and I'll plug it into the RGB to HDMI, and then maybe we can, well, I don't know, see if we see anything visible in any programs or whatever. Okay, so I have the XT IDE there and looking good. Now I found a few PCG utilities which I copied onto the Compaq flash card here. There were two utilities here, PCG Talk and PCG BMP, with PCG BMP supposedly allowing you to look at 640 by 480 by 256 color BMPs. I copied one onto there. Let's see, PCG BMP, PGC BMP, I would say PCG, Flames BMP. Okay, it didn't complain. Let's get the oscilloscope running here. Let's see if anything has changed. And no, unfortunately, nothing has changed. We're getting exactly the same output. So this program didn't seem to complain about anything. It's just sort of frozen now. But my assumption is it would have done that if there were no card even installed. Let's try the PCG Talk or PGC Talk. I probably said it wrong a million times. Enter command, $1. I mean, I don't know. Yeah, this doesn't seem to really do anything. Okay, so I do have CompuShow on here. CompuShow is an image viewer that seems to support like every card. Okay, so let's try to look at this Flames picture. So we're getting a couple different options here. IBM generic CGA. Let's just try that, see what K looks like. Okay, so this is actually using the pseudo high res mode or pseudo low res but high color mode of CGA. So it's reprogramming the rows. And yeah, that's what the BMP looks like. But it did not offer us an option for the PGC, the Professional Graphics Controller, which supposedly it does support. Let's try the setup utility here. Okay, so select video driver. Oh, look at this. IBM PGC 18 is right there. Let's give 18 a try and hit enter. Adapter or interface not found. Okay, so that didn't work. All right, well, I think that's it for this card. I think it's not possible for me to really do any more about this, not unless anyone has any additional information about this, like they can find pictures or they have one and they can let me know that yes, it is missing a module here that is going to prevent this card from working altogether. It's a real shame because 320K of video memory in 1985 is staggering amount of memory. And clearly, well, this thing has got capabilities, but we don't know how to use it. And I couldn't find a single photograph of it or any additional information about this card whatsoever. The one silver lining about this card is this memory is really unusual. I've never seen this stuff before. So if I ever come across another card that needs this type of memory, well, I have an entire board filled with it. So that's a positive. So since this was a fail, this board gets the good old question mark. Don't worry though, by the way, this type of Sharpie comes right off with isopropyl alcohol, 99%. So if I ever do get this card working, some miracle that is, I can take that off and put a check mark there. Alrighty, so moving on. Now we're in the territory of cards that I'm pretty sure are not gonna ever do anything at all, so we're just gonna have to talk about them a little bit. This card right here, this is that video card that has that TI video graphics processor on it and a ton of bodge wires. Well, it turned out that I have another one of these cards. So I forgot about it, but it was in a mail call episode and this was sent in by a viewer on, I don't know, Super Mini Mail Call, like episode 7 or something like that. And take a look at this. This is the exact same card, although this has this color expansion card, I don't know, module on here. Now, what this card actually is, and I identified the brand name Vectrix in the last video, but it turns out this card is called the EX1280. There's a little bit of information on bit savers, where there's actually a photograph of the front and back of this card, including this module here, but that is it. There's no drivers, no manuals, nothing else really about the fact this card exists other than I think there were some tiny blurbs written in tech magazines, kind of like with that last Orchid card. And that's all there really is to it. These two cards here are not even exactly the same. Notice this has two crystals here, and on this one they're side by side. So there's a slight difference in the revision of these two boards. They're very similar on the other hand. This has additional RAM here, plus this module, of course, but the DAC and everything else is somewhat similar. Looking at the back of the board that I've shown previously on the channel, well, there's no bodges on this one, but this one, on the other hand, as we said, it's bodge-tastic. Now, I did a ton of looking with the microscope to look for any evidence of any bodges, and whoever did the soldering on this thing, there's a lot of flux residue, so it's actually really easy to see where these bodge wires have been attached. And you can see here there's been some rework. If I zoom in right here, you see all this flux residue rework. Well, unfortunately, for this little wire here, there is just no evidence of where this was attached. It doesn't make sense like that it would be over here. There's a little bit of flux there because it's too long. So I kind of looked in the area over here, you know, where this wire reached, and there's just nothing. I couldn't find any evidence of where that wire went. Now, this wire was also detached, but it seemed like it probably went right to that point right there. And there's a little crystal oscillator on this side of the board there. So someone has bodged that on there. So I reattached that, but without this being in the right place, I don't have a lot of confidence this can work. Now, people pointed out that bodge wires aren't always there to fix functionality. Sometimes it's a stability thing, and it will work without it. It just maybe will crash or be less stable. Problem is with this board is it's in such rough shape, and it's clearly missing whatever this add-on board that this thing has. So I don't have a lot of confidence that this thing's gonna work. But the worst thing is really though, is that when I got this thing back in on that mail call episode, I never got this board to do anything either. Now, I did do plenty of testing off camera, never got to do anything. And unfortunately, none of my viewers were able to come up with any additional information, basically manuals or software for this card. So really, it doesn't really do anything. Now, what we can do is plug in this working card here into this motherboard here. Well, working, better shape at least. And let's see if we get anything out of this card whatsoever. Now, I don't have the CGA card plugged into this thing. It's just the post card and my IDE card. So when we turn this on, the system isn't even posting. Let's just try that one more time. Oh, now it's posting. Okay. So it's beeping and it's stuck at 40. It's acting as if it has no video card installed in the system at all. Now, of course, the thing is, this has got some switches on the back, and maybe it can act as a video card, but the switches are in the wrong position. Can't really say, but what we can do here is we can plug in the CGA card here, and then we can kind of look around and check it, I guess, and try to see if maybe the ROMs show up in there or something like that. I did dump the ROMs, and there wasn't really any kind of like text strings or anything in there to give away anything. The system is not even posting right now, just sitting there with dashes. Okay, there we go. Now keep in mind that this card might only work with a monochrome card, so we're going to switch this into mono mode. There's a little toggle switch here. All right, in mono mode, the system is booting without any issue. It's seemingly booting without any issue. Let's try C-Show. Maybe C-Show has something we can do with it. Oh, attempt to identify Super VGA, not VGA. Okay. TIGA, let's try that one. Let's try that one. I think TIGA is typically the Texas Instruments, like these types of cards. Adapter not found. Yeah, okay. And how about this 11, DGIS? Adapter not found. And I don't know what else it could possibly be in here, but I think, like I said, there is really just no chance of getting this thing working in any kind of reasonable fashion. Now, this card here has been in the computer and turned on for a little while. Oh, it's really stuck in the motherboard. It is quite warm, so it's definitely getting power. Oh yeah, that chip is really hot. Everything on here is quite warm, so it's running. So I think that's about as much as I can do for these cards. The fact is I have a really pristine example, so if we ever turn up the drivers and the manual for it, then I can actually try to get this thing working. I can certainly figure out how that video connector works and wire up a modern monitor. But as for this card here, this bodge-tastic one, probably never going to work. The only good thing about it is potentially it could be repair parts for this card. But the problem is, of course, as I just mentioned, without knowing how to use this card, there's no chance of trying to repair it. That's kind of unfortunate, isn't it? Okay, moving on. This is the Periscope, and I did wash this, so it looks really clean now. I haven't tried to repair the ribbon cable, it's just that cut, has that cut in it. But what I did do is I tried to repair, let me just put this down here. I tried to repair this. Take a look at those pins now. They're not perfect by any means, but they are a lot better than they were. Now, people mentioned that this is a sacrificial socket, so I could pop this off and try to replace it. I don't really know if these pin grid array type sockets are easily available, and if they are, like, what is it going to cost, like 50 bucks or something to buy a new one? But I guess worst case scenario is I could try to pull one off a motherboard. I'm pretty sure I have a 386DX motherboard that is scrap, like it has really bad damage on the motherboard, and I keep those around for you know, rainy days. So I might be able to desolder that, and then if this does end up breaking or whatever, the pins on here, then I can steal that. But I think I did a pretty good job bending the pins. It's not perfect, but I think with careful insertion into a motherboard, it's probably going to be fine. I think I mentioned this in the last video as a little like overlay that I did manage to find the manual and some software for this. I found the manual for sure for the Periscope 4. I don't know about the software though. There were several different software versions, and what I don't know about the Periscope software is, are those software versions compatible with all the various Periscope cards or what? I looked through my parts and I ended up finding a Periscope 1 card. Now, the funny thing about the Periscope 1 is it still has the RCA connector right here, which I think is a foot pedal or whatever, but it does not have any connector like this to go to a pod. And this is called a pod, by the way, this thing that plugs into the motherboard. So I don't really know how the Periscope 1 works. I'm assuming that card just plugs into a motherboard and allows you to freeze the system, and maybe there's some software that is able to be called up or whatever through like an interrupt. But obviously the Periscope 4 has the capability to interrupt a system like at a hardware level, which means it's probably a much better debugging tool. What I'm probably looking for is someone who has experience in using the Periscope 4 card. That way they can give me some insights into how it works and how the software works and stuff like that. And that would have to be for a future video where we could try to get that card working. And we're getting almost to the end of the cards here. So this is the MQX16. I don't have any drivers for this, but I definitely don't have any pinouts for this DE9 connector here to create the MIDI cables that this works with. It's a MIDI interface card, and I don't know what these RCA jacks here do. Maybe it's like simplistic sound output or something, I don't know. Either way, if anyone has one of these cards handy and they're able to figure out the pinout, all you have to do is use a multimeter to tone out the pins that go to the DE9 here to the two DIN connectors, which are the MIDI jacks, and then I could replicate the MIDI harness for this and then potentially get this working. If anyone's ever used this card and actually had it running in a system, like how does it work? Do you need drivers or et cetera, definitely let me know. There are some jumpers on here as well, so if you have one of these cards that is actually in a working system, if you could let me know the jumpers, that would be very helpful. This card here is an AppleTalk card. This connector here would plug into an AppleTalk transceiver that's designed for the Mac 128 and 512. That has the same exact connector for AppleTalk and Serial. So that's what this card is, and it runs the TOPS software, which says TOPS up here somewhere. There it is, TOPS. So there's special software that was designed for transferring files between PCs and Macs. The thing is, this card apparently needs some drivers, and those drivers are unobtainium or lost. So without those drivers, along with that top software package, and then the similar software that runs on the Mac that's able to talk to this, it's not gonna work. So that's kind of unfortunate. And then that brings us to these cards here. Remember, I had a whole bunch of PCBs and I have a bunch of completed ones. Really no information was forthcoming for the scan cap card whatsoever. But looking at the components on this chip here is an analog to digital converter. And almost certainly what this card is some type of a capture card. Probably can capture NTSC and VGA or VGA video. And it probably is a slow type capture card. It does have some memory on here, so it has a bit of a frame buffer. It's unknown if this can just capture an entire image and then transfer that into your computer. But this was probably designed to just grab still images off of a video signal, potentially used in magazines. You've seen magazine reviews back in the old days where they would show a screen capture that was, from another PC. A lot of times they probably use cards like this, and the video output here maybe it would be captured from a camera or a VCR or whatever like that. So without, again, the software or the information about this card, we're never going to get this working. But yeah, it's a little bit interesting of what this might be. And that finally brings us to this card here, the BlackFoot card. Now, while there's no way for me to actually test this card, I mean, I have a Mac that I can plug into, the drivers and the information on it are not forthcoming, they're not available, they're lost to time. But what my awesome patron was able to dig up on this is a little tiny snippet in a Macworld magazine from 1991. And here's what it has to say about this card. The BlackFoot is a JPEG compliant image compression accelerator with a throughput of a claimed 1 megabyte per second. The board's compression and decompression algorithms are implemented in an onboard digital signal processor, and it comes with a compression application and a Photoshop plugin. $500, Arroyo Technologies, and there is a little bit of information here, just their phone number here. That is it, no address even. So that's pretty cool that we finally know at least what this card does. It's just too bad we could never actually get this working. Now my Macintosh 2CI has an 040 accelerator in it, and of course it's probably a similar time frame to when this card was out. And when you load and save JPEGs in Photoshop, or I have a little JPEG image viewer, it's slow. It's really slow. And if you load a high resolution JPEG, I mean, it takes a long time to display that image. We're used to JPEGs opening essentially instantaneously now, even on like things like your phone and stuff like that. But back in 1991, JPEGs were extremely processor intensive. And I guess cards like this, which use these DSPs here to really accelerate that, were, well, the bee's knees. So it would be kind of cool to get this thing working. If anyone can dig up the software for it, it'd be fun to see if any of these cards do work, and we could do some, well, benchmarks and stuff like that and compare it to the software JPEG compression and decompression versus having this $500 card in your Macintosh. Okay, so that's really it for all the cards that were inside that box. What I think this video highlights is I didn't have a lot of success getting the unknown things working, like the cards like this and the stuff like this. And what this really highlights is there were a good number of years when there was lots of stuff out there in the computer market, I'd say from the mid 80s into the early 90s, where a lot of the software and information on this stuff is just lost to time. These companies like Arroyo Technologies and this scan cap conversion technology, and even Orchid, I mean, that was a big company, but these smaller companies, they kind of came and went, only existing for a few years, maybe getting bought up by someone else, and then all their products were just discontinued. A product like this JPEG compression decompression card, just had a very limited useful lifespan, because you know, how much longer after this did Macintosh switch to Power PCs, where there was now enough processing oomph to decompress and compress JPEGs really quickly, potentially even faster than a card like this. So this thing was just of a very limited usefulness, and who knows how many they actually sold, and therefore the software and the documentation is just lost. All the information is lost to time. All we're left with is these little snippets that were in the back pages of the magazines that just talk about the fact that a product existed, but that's it. No magazine reviews, no nothing. The Vectrix card here is another example of that. This company had been around for a number of years, but I don't think they survived much longer after this. There were bigger companies in the market that had similar cards like this, and then of course VGA and Super VGA came out, and it just rendered all of these cards obsolete basically overnight. And it seemed that these were such niche cards for their use case that the magazines didn't even do reviews of these cards or comparison reviews, or at least not this card. Now this Orchid card is a bit surprising. Orchid was a successful company and they made a whole line of VGA and EGA cards that were very popular. I have a bunch of other Orchid VGA cards and those have information on them. Not a lot, but at least I can find out what like the dip switch settings are and stuff like that. But being VGA cards, they're VGA compatible, so you don't need special drivers and whatever for them. You just really need to know how the dip switches work. And luckily that stuff has survived. But the special utilities for those cards, because some of them had some extra capabilities, that stuff generally didn't survive. But yet with this card, there's just the tiniest information, and it's not even 100% clear if that little snippet that was found in the magazine is even this card exactly. We don't know for sure. But without a photograph of the card even, how are we to know? How are we to know if this is even complete? I think what I'm getting to here is I just continue to be amazed at how many cards existed from all these small companies and big companies where all the documentation and all of the information is just lost. I'm pretty sure that somewhere in boxes stored away in people's attics or garages or basements or whatever, some of the documentation does exist for this stuff. But it's very unlikely that stuff is ever going to be uncovered and actually scanned in. And most likely it's all just going to get thrown away. And then that's that. Okay, I'll get off my soapbox and stop complaining here. This video wasn't a total loss. I got a working motherboard, I have a bunch of sound cards and some video cards that work, and that is pretty exciting. And you know, I exposed the internet to some of these weird cards, so maybe someone watching at some point in the future will go, hey, I have the information about those cards, and then we'll get that on archive.org, and then maybe we'll bring a little bit of information back from the unknown into the general public for our future generations. Now, what I'm going to do with all these cards that I can't get working is I'm going to put them into a box like this, which has a bunch of other cards in there that are in a similar boat that don't work, or they don't know how to make them work. In fact, this video card right here was inside this box right here in an anti-static bag with the original letter from the viewer. So I will make some space in here, and plus I have a couple other boxes with similar cards. So I'm going to stick all these other weird random cards into here for a future time. If we ever do uncover information about these, I can go and grab it, and then maybe we can try to get it working. Might make an interesting video, or these cards may never see the light of day again. If you have suggestions or thoughts on these cards or any information you might be able to dig up or find, definitely put a comment down below. And in fact, if you're watching this video at some point in the future, I don't always see comments from older videos especially, so definitely please email me at my channel about page. There's an email address there, and just let me know that maybe you have uncovered some interesting information about one of these cards, and we could maybe get it working. So that's gonna be it for this video. Thumbs up if you liked it. If you didn't, you know what to do. Huge thanks to my patrons. They make this literally possible. Their names are scrolling up the side of the screen, and they get early access to videos and behind the scenes stuff and live streams and stuff like that. So if you want to become a patron, you could do so at the link in the description below. And I guess that's gonna be that. So stay healthy, stay safe. I will see you next time. Bye.